Okay, we're going to solve another rational expression. And it looks like my screen's a little crooked, so I apologize for that. Hopefully that's better. All right, so here's the problem what to do. 9x over 3x minus 1 equals 2 plus 3 over 3x minus 1. There is nothing to factor. However, I'm going to make a note, and I'll just work this out in case some of you aren't sure. I want to determine what value x cannot be equal to. In other words, what value of x would cause the denominator to equal 0. Actually, these two denominators are the same. So in a sense, what I want to figure out is what value of x would cause 3x minus 1 to be 0. And actually, it's x to the 1/3. So the bottom line is, and I'll write it down here, when it's all said and done, x cannot be equal to 1/3. That cannot be one of my solutions, or the solution, because that would cause me to have the 0 in the denominator. So I'm going to go ahead and try and solve this problem. I'm going to clear the fractions by multiplying both sides by the LCD. Since there's only one denominator, or at least there's two denominators, but they have it's the same value. I'll multiply both sides by 3x minus 1. I'll squeeze it in here. Hopefully you get the hang of this, that the 3x minus 1 and the 3x minus 1 on the left-hand side cancels out. So I'm left with 9x on the left-hand side. I have to distribute the 3x minus 1. So I have 2 times 3x minus 1. And for the second term on the right-hand side, the 3x minus 1 and the 3x minus 1 in the denominator cancels out. And now it looks like a pretty easy equation to solve. So if I multiply out the parentheses, 6x minus 2 plus 3, plus 3. Negative 2 plus 3 together is 1, so I have 1 over here. And I'm going to subtract 6x from both sides. So 3x equals 1, and now to solve for x, I divide both sides by 3. All right, now there's a special reason why I chose this problem. Some of us were so used to solving equations that as soon as we get the solution, it feels like we're done and we're ready to move on to the next problem. But you've got to remember, these equations where you start out with a rational expression, you're not done until you check your domain. And by checking the domain, I'm basically saying, is the solution of 1/3 an okay solution? So I go back, and I remember at the beginning, I determined what value of x would cause me a problem, and lo and behold, I determined x cannot equal 1/3. So here's a conflict. At the beginning, I said x cannot equal 1/3, but then I do the math, and it says x equals 1/3. So who wins this contest? Up at the top. This is the winner. X cannot be 1/3. So I sort of go like this, and I say, what's my solution? There's actually no solution. All right, so that's an example of why you have to check the domain. Whenever you get a solution, remember to go back, look at the original equation, and make sure the solution is okay.